Every single app you use, Gmail, Instagram, Uber, Spotify, they all speak the same language. And if you're building back-end systems, you need to speak it too. Welcome to this explainer. Today we're decoding the REST API, the thing that sits between every client you build and every server you deploy to. By the end, you'll understand the anatomy of a request, the meaning behind every status code, and why REST still dominates modern back-end architecture. Let's kick things off with Section 1. The simplest mental model for REST that actually holds up. Imagine you walk into a restaurant. You sit down, you're hungry. Now, can you walk into the kitchen and start grabbing ingredients? Absolutely not. The kitchen is the server. It holds all the data, the recipes, the ingredients, the finished dishes, but you don't get direct access. That would be chaos. Instead, a waiter takes your order. That waiter is the API. It takes your request, brings it to the kitchen, waits for the food, and brings back exactly what you asked for. The response: client, API, server, API, client. That's the loop. Let that sink in, because every REST call you ever make follows this exact pattern. Moving into Section 2, let's break open the URL itself. Every REST call starts with a URL, a uniform resource locator. And honestly, most engineers glance at URLs every day without really reading them. Let's fix that. First, the protocol, HTTPS. This tells the client we're speaking HTTP, and we're doing it securely. Then the domain. And here's where it gets interesting. The endpoint. This slash separated path tells the server exactly which resource you want. Take this URL. That users? That's the resource. That 42? That's a path parameter. You're saying, give me user number 42 specifically. Now, add a question mark and suddenly you're filtering. These are query string parameters. Key equals value separated by ampersands. You're saying, give me users, but only the active admins. Same endpoint, same resource. Completely different data coming back, just from tweaking those parameters. This is the language of REST, which brings us to Section 3, the 5 verbs that control everything. Get, fetch data without changing anything. Post, create a brand new resource. Put, replace the entire thing, every field. Patch, just tweak one field. Delete, remove it completely. Here's the trap that trips people up. Put versus patch. When you put, you send the entire resource and every field. If you forget a field in your payload, it might get wiped. When you patch, you send only what changed. The server merges it in. Get this wrong in production, and you could accidentally nuke user data. So let that sink in. If you're just changing an email, patch. Don't put. Moving into Section 4. Let's look at what actually travels across the wire. A request has 4 parts. The method, which verb you picked, the endpoint, where you're sending it, the headers, which are metadata about the request, and optionally a payload, the JSON body with your data. The response comes back with 3 things: a status code, was it successful? Headers, and metadata about the response, and a body. The actual data you asked for, usually in JSON. Request goes out, response comes back. Every single time. And the status code tells you exactly what happened. 200 level, green, success. Your request worked. 400 level, yellow, you messed up. Bad request, not found, unauthorized. 500 level, red. The server messed up, not your fault. But your code needs to handle it gracefully anyway. Which brings us to Section 5. REST has been around since Roy Fielding's Dissertation in 2000. That's a quarter century, and it's not going anywhere. First, REST is universal. Any language, any platform, any device. Python talks to Go. iOS talks to a Linux server. As long as they speak HTTP, they speak REST. Second, REST is stateless. Every request carries everything the server needs. No session memory, no remember me from last time. This makes REST APIs infinitely scalable. Spin up 100 servers. Any of them can handle any request. Third, REST is the backbone of microservices. When you break a monolith into dozens of services, how do they talk? REST APIs. Each service exposes its endpoints. Each service is a client to others. The architecture scales because the communication is standardized. Universal, stateless, scalable. That's not a trend. That's an architectural advantage. And it's why REST still dominates, even with GraphQL and gRPC gaining ground. Thanks for joining me on this explainer. If this helped clarify REST for you, drop a comment. What backend concept should I decode next? Subscribe, and I'll catch you next time. Keep building.